our spreadsheets open.
All right, you guys let me know when you're ready.
I'm ready.
Okay. I think I'm ready.
Yeah, I think I am too.
Okay, question number 3. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. I believe that's true.
Yeah.
Pretty sure.
We reject it or we fail to reject it.
Looks like when we reject it, then we have sufficient evidence. And then with the null and the alternative on this one, it's either the means are equal or one or more mean is different. So I'm pretty sure that's true.
Okay.
You guys agree with that?
Yes.
Yeah.
Does that make sense, Jennifer Ward?
Yeah, I read the question and I put true at first, and then I thought, wait a minute. Because my brain is probably thinking not the right way. Because the alternative hypothesis, that's the alternative hypothesis right there.
Yeah, that's right.
Is when we different. So
Yes.
Okay. Because when we reject the null, anyway, okay, you're probably right.
Yes, so no, you're exactly right. So when we reject the null is that all means are equal. So if we reject that, that would mean that one or more is not equal. One or more is different.
Okay.
Does that make sense? So you're saying you're exactly right. It's just kind of like because we're rejecting it, we're saying that it's wrong.
Not
so
true.
That would mean that they can't all be equal.
Okay. Okay.
Okay, question 4 is what requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. Let's see. I do know. Sorry, go ahead.
Just A and B?
I don't think it's A. I think it's just B.
I think it's
I know
B and
for
C.
sure it's B. I'm going to have to look in my notes to see about...
The variances don't have to be equal. It's just that the largest variance can't be more than 4 times the smallest variance.
And I don't think they're talking about the variances in each individual group. I think they're talking about the variances between the groups. Does that make sense?
Right.
So, and the thing that has to be positive isn't anything to do with the requirements. It's just saying that the F distribution the values will always be
okay.
Positive.
So I don't think that's a requirement. I think that's just what's supposed to happen.
So in my notes, I have that variances are equal for each group.
I have something similar written down, that the populations have the same variances, that is a requirement. Does that mean
because
equal,
they're considered
though?
equal? Yeah, but that doesn't mean exactly equal, because we've learned that. Because, yeah.
So when they say variances are equal in each group in this question, does that mean the variances within each individual group? are the same, or that they're equal between the different groups. I'm not sure what
Let's see.
wording which they mean.
Okay, so what, can you explain to me specifically, like, what is the variance?
The variance was, where did I write that?
Like, I understand that the equation for F is the variation among sample means divided by the variation among individuals in the same sample. I mean, I guess I
Do you
I'm just
remember
not
the
100% on what exactly they're referring to here.
Do you remember the chart they showed in the video?
Yeah, the X's and the O's.
Yeah, the X and the O's. And if variances weren't equal, the X's were all on one side, the O's were all on another.
Right.
And
Okay.
if they were equal, then they were kind of mixed up. So you were going to have, you know, some X's and O's, both that had low values and some that had high values. I think
Okay.
that's what it's referring to.
I think, Jen, you're right, that C is one of the answers. It says that the variances are equal for each group. If the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal.
Mm-hmm.
Okay, let's go ahead and do the C then.
Yeah.
Do B and C.
I think you guys are right. Yeah, I think C is one of those.
To check if each group is normally distributed, do the following. Construct a scatter plot of the data, construct a histogram of the data, construct a QQ plot for each group. So when we're looking at normally,
QQ plot, isn't it?
for sure a QQ plot. But can't a histogram show you that as well?
Except for the histogram is always going to be right skewed, right?
On these, it's supposed to be.
These will always be right skewed, but
I don't know if each individual one will be, but the histogram of all the data will always be right. And we're
but a
testing.
histogram will still show you if you've got huge bars and small. I mean, it'll still show you if there's a normal distribution.
It will kind of. But if you read the question, it's asking about each group, and then in the histogram it says of all the data. So if you take all that data, in the histogram, that's not going to tell you about each individual group.
Gotcha. Okay, that makes sense. So then just C?
I think so.
You can only pick one, so yeah.
Oh, well, that's good. You know what? I would have eventually figured that one out and been like, well, I know it's a QQ plot, so let's go with that one. Perfect. Question 6 is, we assume the variance in each group is the same if the following happens. Let's see.
So B.
If the largest variance is less than 4 times the smallest. Yeah, I'm thinking B.
Yeah, that's what I think.
Okay, question 7. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples? 4?
I think there's 6.
Well, are they asking for pairs or samples?
They're asking how many pairs are there if there's 4 samples. So you have to do 4 and 3, 4 and 2, 4 and 1, 3 and 2, 3 and 1, 2 and 1.
I think it's 6, yeah.
Okay, hold on one second. Let me just think about this.
If you draw out boxes
Mhm.
Uh-huh.
that way, that makes it easier.
So you're writing like 1 and 4, 2 and 4, 3 and 4, 2 and 1, 2 and 3, 2 and 4, 3 and 1, 3 and 2, 3 and 4, like that kind of a thing
Yeah.
Mhm.
for all of them,
Yeah.
and then you count how many pairs you have.
Yes.
But you can't repeat them because it's already been done.
Yeah. So 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4.
Was that 6?
Yep.
Okay.
Yeah. There's 3 that'll match up with number 4, and then there's 2 that'll match up with 3, and then there's 1 that matches up with 2. If that makes sense.
Perfect.
So the easy way to do that is
Yeah.
if it's like if you have 8 samples, you start at 7 and you add 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, and that'll give you your number. You just don't, if there's 8 samples, then you start at 7. If there's 9 samples, you start at 8. If there's 12 samples, you start with 11. Does that make sense?
Oh, yeah, that does make
Add
sense.
every number. You add every number below that to it once.
That's a good trick.
Okay, that was awesome. Okay. That makes sense to me. Okay. I'm just writing this down really fast. Sorry.
No,
Okay. All right, moving on to the next question. Here's the scenario. What is the smallest variance for the 6 groups round to 3 decimal places? Okay.
Okay, so we need our data, huh?
Soccer shoes. There are 5 types of shoes, A, B, C, D, and E. Okay.
And I figured out on that other, remember the one that had all of the data that was all mixed up with the cars?
Yeah.
So
Yeah.
I called my son and I said, there has got to be a way to do this. And he's like, oh yeah, just highlight everything except line, that shows all of the headings, and then go to sort, and then it will ask you, do you want to sort by car type or, and then you can choose which one you want to sort by, and then it puts all of that, then it just sorts it all. It was really, really slick and fast. I'm like, oh, but they're already done. I didn't do it until Saturday, so I figured we're already finished.
Yeah. Cow. I'm like, that's ridiculous.
Yeah, it was crazy. I don't know. I'm kind of over this whole copying.
Copy and paste. Yeah. Me too.
at least we don't have to do it all by hand. Can you imagine?
By hand. I know. It could be a lot worse. When they were saying it would take you an hour to do the one problem.
Yeah. I'm like, oh, I'm so glad we're going to have to do that.
Did you guys see in the question, do we need to do the socks as well?
Yeah.
So also paste the socks in there?
Mm-hmm.
Okay. me know when you guys are done and we can kind of compare numbers to make sure we are all on the same page.
Okay, I'm done.
I'm not.
I've got mine in.
Hang on, I'm almost there.
Okay, for those of you that have it in, for variable 1, is your mean 33.1?
Yeah.
Variable 2 is at 32.7?
Mm-hmm.
29.450?
Yeah.
32, 32.2, and 35.25?
Yep.
Mm-hmm.
Okay. So the smallest variance that I'm seeing over there is 27.208.
Yep.
Yeah.
I've got for C.
Uh-huh.
Yeah.
So that'll be number 8. It looks like the smallest variance. Largest. Did you get it all in there?
Yeah, okay, so what is the smallest group? So, okay, so I think I have the 27.208. Sorry, I was not paying attention to it.
Perfect. Yep. That's what we got.
All right. What's the maximum?
Did you guys get 53.158 as your largest variance?
Mm-hmm.
Yeah.
Okay. The test for equal variances is satisfied for this data. So if we took the smallest one, what is it, and multiplied it by 4,
Yeah.
then, so yeah, we're good, because that would be, yeah, much bigger than 53, so.
Oh, seriously, now I have to do that.
Really?
You know what? Why don't we split it up so that we do 2 instead of, or 1 or 2 or 6?
I'll do 5 and 6.
Okay, I will do 3 and 4.
I can do A and B.
Okay, we gotta do some QQ plots here.
My other- Where did my other
And
spreadsheet
then they're
go?
Actually, can't we just do all the QQ plots at the same time, just on that same screen?
how do you do that?
Go up to Insert, and then they'll have like charts in the middle.
Okay.
Click the little arrow. Oh, first you have to highlight the information you want on your QQ chart.
Okay.
So, okay, you're gonna have to explain this to me.
Yeah, me too.
Okay, let me see if I can share my screen with you.
Because I thought you could only do one set of data at a time.
That's what I thought
This-
too, but maybe.
Oh wait, I'm thinking box plots. I don't know if this does QQ.
So you
I
have to
don't
go to
know.
the other spreadsheets, the quantitative descriptive statistics to do the QQ plots.
Yeah.
Right.
Let me look and see if this will do QQ plots, because it's got a whole bunch of different charts it'll do.
Where?
Okay. Well, 6 is normal, just so you know.
6 is normal. Okay, I think if even just one more is normal, I think it's going to be true.
Well,
So I'll do 4.
Yeah, I think we'll have to do them the old-fashioned way. I'll do A and B. Nobody's done those yet, right?
No, I'm doing
and
third variable.
the 5th one.
I just did number 4. Oh boy.
Boy.
4 is not normal.
Well, that's our answer there then, right? Because it only takes 1.
I think so. Does someone want to just check me on it? Because I would hate if I screwed something up.
Here, I'll do
But
it.
it's definitely not a normal distribution unless I've done something wrong over here.
Yeah, it's normal. You
It
have
is
to
normal?
sort it from smallest.
So did
You
you
have to sort it from
put it in there?
smallest to largest. You have to sort it.
Yeah, and then it makes it a normal plot.
Oh,
Yeah.
okay. So give me 1 second here. So tell me how I sort it from.
If you go up to the top bar on your Excel and it says data, you have that.
Okay.
Click on that and then go to sort.
Sort. Okay.
And then it should ask you how you want to sort it, smallest to largest or.
Okay. And then a quicker way to do it
There's usually also a thing, but I have my screen.
is.
Goes down.
Yeah, I was gonna say I just go all the way to the right.
Yeah.
There's a sort and filter button already on there, and then just push it, and then it'll do it.
Okay. So, okay, you're right. It is normally distributed.
Yeah.
Okay, that makes sense. I gotta remember to do that. I mean, I should have thought of that, but okay.
Okay, so we've got true for number 11.
B is debatable. Did any of you guys look at B? Take a picture of it and I'll send it. You can see what you think. It looks normal, but I'm never really sure what they think is normal, what they don't.
Yeah,
You know?
Let me paste
Right.
it in here.
that is true.
Let's see.
I think it's pretty normal.
Oh, did you get it up already?
Yeah. I think that there were some in the practice that seemed
Yeah.
to do that, and they'd say, "Yeah, it's pretty normal. You know, it's not exact, but it's close to normal."
I
Yeah.
would say it's normal. Yeah.
Okay. Okay, sounds
So
good to me then.
True for number 11 then.
Yeah.
Mhm.
Okay, it says perform an ANOVA test in SPSS and observe that the p-value is 0.081. Remove the SOX data and perform the test again. What is the p-value when we remove the SOX? Okay.
Okay, so 081. Okay. Stocks were
What's
the
the-
last group.
Variable 6, right?
Well, mine changes to 301 or 310. 0.310.
My p-value
Okay, so
didn't.
we
Oh,
took-
yes, it did. 0.3.
0.309 is what I got.
Yeah, so
Yeah.
310.
Then no, actually, if we round it to the 3 spaces, it's still going to be the 309 because after the 9's a 2.
Yeah.
Oh,
So 0. Let's see, what is it? 0.309.
yeah.
Okay. The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left of the F statistic?
Right.
Right.
You're right.
Right. Because it's always positive, right? Oh. Okay. Okay, it looks like we're doing the beef
Hot
poultry
dogs.
for each of the 54 hot dogs. Okay. Dang it.
So what are we just beef, meat, and poultry? So we have six variables.
We're doing calories first, they said.
Right.
I
Okay. I'll do beef.
before hot dogs analyzed.
Do
Examine the calories first.
I'm sorry. So you said calories needs to go first.
Yeah, that's what they are.
What they said we were going to look at first.
So should we
So-
just do calories for beef, meat, and poultry then? For A, B, and C? Or
That's-
1, 2, and 3?
That's kind of what I figured they wanted us to do.
Okay.
Trying to get the stuff deleted out of my stupid. I'm so past this. Okay. So what are you doing, Jen?
Me?
Uh, the beef is normal.
Oh, you're doing QQ plots?
Uh-huh.
Yeah.
Okay, so I'll do the meat.
Or are you guys not putting them all in the thing? I guess we could break it up.
Well,
Because right now they're just asking for
Asking if they're-
QQ plots.
for the Q plots.
Who knows what they're going to ask next?
So is there a QQ plot that hasn't been done yet?
I just did the meat and it's normal.
So we have poultry.
But we do need
So
to,
poultry is normal.
but it's also asking about the variances. So we've got it, we have to.
Yeah, the variances are all really close. The lowest is like 508.566, and the highest is 636.846. So the variances are good.
So is the answer A for 14?
I'm just putting everything in so that I've got it all.
So did you guys do the first 3 variables was calories and then the next 3 variables in that same order of sodium?
Yes.
I
That's
don't
what I'm
think. I don't know.
I didn't do that. I just put in calories because if we add sodium to the calories, isn't that going to change like the p-value and the F and
Yeah.
stuff?
Yeah.
Yes. So it probably just depends on what they're going to ask us. So I guess
So let's examine the calories first. And so if this is assumptions, okay.
so 14 we got A, right? 15.
Yeah.
I think, yeah, I'm going with A.
Because we checked the QQ plots and we know the variance is the smallest isn't 4 times
Right.
the larger. So now we need to run a ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.074, and that P equals 0.000.
Yes.
Okay.
Let me just click on mine and see if I've got.
4.000. Okay. What conclusion can you draw?
2 and 51. The means. Same.
I think it's A, right?
So p-value.
So we reject it.
So then at least one of them is different.
Different.
P is low, rejected. So we're going to reject the null.
Yeah.
We have sufficient evidence
claim that all 3 hot dogs have a different.
I think it's D.
Oh, I haven't gotten that far. There,
Yeah.
I can see that one. Yeah, I think it's D too.
Yeah. So D.
Yeah.
Now sodium levels.
So do you think take the calories out?
Yeah.
I would, because otherwise it's going to mess up our NOVA test stuff. The descriptive statistics would be okay, but the ones down on the NOVA test, yeah.
Oh. Wow. I wonder if I did it wrong.
Okay. So the variances are
Okay.
good for the 3. The smallest is 7,180 and the biggest is 10,492. So we know that that's that assumption has been met. So now we just need to do the QQ plots.
So for the chicken, it's normally distributed.
Okay.
It's saying that we should see the QQ plot for poultry suggests a possible problem with the normality assumption.
So let's look at, I would imagine it might be variable 1 because the variance is so high, do you think? No, it doesn't look any less normal than some of the other ones that we've
Yeah.
done.
It does look kind of snake-like a little bit.
I would say that is less normal than other ones that we've observed.
Well, variable 2 has a dot clear down on the horizontal axis. So variable 2, I guess, would probably be, and then it's got one that's, you know, a little bit above.
Are you looking at poultry or meat?
Meat. At
You're
meat.
looking at meat. Okay.
So look at that one and see what you think.
Okay.
So which one was for poultry? That they tell you which one is bad.
You do?
Yeah.
See that?
Well, if you look at the QQ plot, it's a little more than.
I didn't think that the poultry is the third one, right?
Uh-huh.
Yes.
Well, I felt like it was not much different than the one that we looked at before, where we thought,
Yeah.
So the second one is definitely more normal than poultry, in my opinion.
Yeah. It's
Second one looks very normally distributed to me. Poultry, I mean, it's just hard to know because it's a little bit more off than the others that we've observed, but is it still considered normal? I mean, that's like debatable. I don't know.
I think I would go by what they say in the
yeah, I think so too.
I agree.
in the thing, and assume that that's not normal, that it might be a problem. Yes,
So would we go with the last one? Or excuse me, not the last one. Let's see. It's
C, I think.
I think
C.
I think so, because that's saying that it's not safe to assume that they're normally distributed, but that the variance.
Because we know the variances are equal.
Uh-huh.
So C.
Right.
Okay. All right. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all three groups. What is the p-value for this test? Okay.
So I have 0.179.
Yeah.
Oh, that's what I got.
Yep. Okay, and then if the level of significance is 0.05,
And I think we have, it's A, right? We're not going to reject the null, right?
don't reject the
E.
null.
Because A is kind of saying, yeah, the hypothesis is correct, and what we want to do is reject or not reject the hypothesis. I
I
think
see what you're saying.
B.
So we want to fail to
Don't we
reject
have-
it.
Yeah,
Let's see.
yeah.
So there is insufficient evidence is what we want to say.
There are none of them that say insufficient evidence.
They must be worded funky then or something.
Well, B says we do not have sufficient evidence. That's the same.
Okay, that's got to be it then. To reject the claim that all three hot dog types have the same mean sodium levels. I would go with B.
Sounds good to me.
Wait, so we are not rejecting the null, right?
We are
Right.
failing to reject.
We're
Reject
failing to
the null,
reject the
yeah.
null. And this is saying that we don't have sufficient evidence to reject the claim that all three hot dog types are the same. But the null says that they are the same.
Yeah. So we're saying we don't have enough evidence, or we're failing to reject the claim. It's just, we say we fail to reject, and they say we don't have enough evidence to reject.
Okay,
So
let me just read through that. Okay, so we do not have sufficient evidence.
Which saying we do not have sufficient evidence would be the same as saying we have insufficient evidence. Which
Yeah.
is what we would say if we were going to fail to reject the null.
Okay. Oh my gosh. All right.
Tricky on us here. The questions are getting tricky on us. I mean,
Yeah.
all right, I can, that's all of them, right? I can submit. Let's see what we got here. Looks like we got 20 out of 20.
Yay.
Yay.
2%.
All right.
Good job, group.
All right, thanks.